java.lang.runnable interface. Steps to develop multi-threaded application by implementing java.lang.runnable interface. See, you studied by extending java.lang.thread class. This is by implementing java.lang.runnable interface. But why two ways? That is, I'll explain. First, this after completion of this one, why two ways you'll understand. Now, you already studied steps to develop multi-thread application by extending java.lang.thread class. What is the first step there? That extend thread class here. Create a class that implements java.lang.runnable interface. Create a class that implements java.lang.runnable interface. Create a class that implements java.lang.runnable interface. There, what is the second step? Override run method. Here also same. Override run method. Override run method. Override run method. Next step. There, what is the next step? Here same. Write child thread task code in a run method. Write child thread task code in a run method. Write child thread task code in a run method. Not on. Fourth step. Write main method. Write main method. Fifth step. Create an object of current class. Create an object of current class and assign to runnable reference. Create an object of current class and assign to runnable reference. Create an object of current class and assign to runnable reference. Create an object of thread class. Here, these steps are different. By passing runnable reference in a thread class constructor. Next, call start method. Next, write main thread task code in a main method. Write main thread task code in a main method. By extending thread class 7 ways, 8 steps. Okay. Here, just 2 steps somewhat different. Remaining all steps almost same. Just 2 steps, 5th step and 6th step somewhat different. Remaining all steps are same style. Okay. Is it over? Writing program style almost same. Only two steps. Step number 5 and 6. This 5 and 6 only somewhat different. Remaining all same. Now, according to this, we'll see the program. Is it over? See, according to steps, what is the first step? Create a class that implements java.lang.runnable interface. What we have tried? Class demo implements runnable. Okay. Class demo implements runnable. Now, class demo implements runnable. Runnable interface in which package? Java.lang. Is it required to import? No. Why? Implicitly imported. Default package. First step completed. What is second step? Override run method. What we have tried? Public void run. Override run method. Okay. Next. Write child thread task code. For loop, suppose integer I equal to 1, I less than or equal to 10, I plus plus 10 times. I am printing child thread. Okay. Now, task code completed. What is next step? What we have tried? Public static void main string args. Okay. Public static void main string args. Next. Create an object of current class and assign to. Now, once again, read that line. Create an object of current class and assign to runnable reference. Think yourself and give me answer what we have to write. What do you write? Runnable R equal to new demo. Okay. Now, runnable R equal to new demo. Here, create an object of current class. Which is current class? Demo. Okay. Create an object of current class. So, demo class object created. And assign to runnable reference. Runnable is interface. Is it valid or not valid? Valid or not valid? Valid. Here, which class object created? Demo class. Which interface reference? Runnable. It is subclass. It is super interface. Interface also class generated, dot class. You can call it a class also. All interface are class only, all enumeration class only. Every interface one dot class file generated. Every enumeration also one dot class file generated. Every record also one dot class file generated. The enumeration records not completed. Next topic, lost. Okay, I'll teach. Now, this is over. It is upcasting. Subclass object created, super interface reference created. It is upcasting. Now, what is next step? Create an object of thread class by passing runnable reference in thread class constructor. What we have tried? Thread T equal to new thread of R. Already two constructors I given, you can check it notes. One constructor doesn't take any parameter. One more constructor takes runnable. Okay, the two constructors already given. Here, thread class constructor, I am passing R. are nothing but runnable. Okay. Now, here, if you write like this, in a previous program, we didn't create thread class object, but here we created thread class object. Why? You'll understand. What is the next step? Start method in which class? Thread class. Thread class reference already is there, no? What we are trying? T dot start. T dot start. Next, write main method, main thread task code in a main method. Suppose for loop integer I equal to 1, I less than or equal to 10, I plus plus. Here, system dot out dot println main thread. Okay. Now, your task part leave it. First task part leave it. This is task, that is task. Remaining code is common code for every program. Now, you observe. Now, first, control comes to main method. Now, first control comes to main method. Okay. Control comes to main method. Now, after this, open brace. After this, it comes here. In this line, which class object created? Is there a demo class constructor? No. Will it Java compiler provides? Yes. In that constructor first line, what will be there? Super. What that super will do? Super class constructor. Which is super class? Runnable is class? No. Which is super class? Which is super class? Object is super class. Now, runnable is interface. Now, here, demo class. Demo class is our class. Okay. In the demo class, any constructor written? No. Will it Java compiler provides? Yes. Implicitly, Java compiler provides one default constructor. In that constructor, first line, what will be there? Super, implicitly present. And super, what it will do? Default constructor of super class. Which is super class? Object class constructor called. Here, thread class constructor not called. So, here, new thread will not born. Then control comes here. Here, which class object created? Then which class constructor called? Now thread class constructor called. Now child process created. So from this, one child. From this, one child will born. And it is main. This is child, this is main. Okay. This is child thread. This is main thread. Now, child thread, main thread. Here, T dot start. When which thread will start? Here, T dot start means child thread will start or main thread will start? Child thread will start. Main thread continuously will run. Okay. So this is started, ready. Start method implicitly calls run method. Then control comes here. Okay. Next, here open brace. Here, this code executed. At the same time, this code executed. Whatever you written here executed, whatever you written here executed, both will send the output to output window. Now it is called multi-threading. Now write this one. Is it over? In which line thread generated? Thread T equal to new thread of R. So in this line, new thread will born. But yesterday you studied while creating demo object only thread will born. Okay. Reason extends thread. Because demo object, if you create thread class constructor called. In the yesterday program, we didn't create thread class object. We created only demo object. Reason, super class already thread class. That's the reason it is called like that. Okay. Here demo object if we create, super class is object class. Object class is super class here. And that's what here explicitly thread class object required. Explicitly thread class object required. Without this, it is not possible. Okay. Is it over? Here, whatever you write here, both will send output to output window. Okay. Now, if we don't write this one, new thread also will not born. It is not possible to call start method also. Okay. That's what it is compulsory required here. Now, new thread will born in this line. Like already studied, when new thread will born, whenever thread class constructor is called. That's what in this line thread will born. But in the previous program, demo object created, then thread class is called because super class. Okay. Now I'll write some code here for integer I equal to 1, I less than or equal to 10, I plus plus. Here system dot out dot println child thread. Here for loop integer I equal to 1, I less than or equal to 10, I plus plus. System dot out dot println main thread. Okay. Now you observe. File save. Can you predict the output? No. Output we cannot predict. See, Java C demo.java. Java demo. See, main thread, child thread, mixed. See, main thread 3 times printed. Child thread 5 times printed. Again, main thread 2 times printed. Child thread 2 times. We cannot predict. If I execute again it may be different. See, 1 time main thread, 4 times child thread. We cannot give a guarantee how it is going to run. Okay. Now here, how many threads are there in this program? How many threads? 2 threads. One is main thread, one is child thread. Main thread default name is main. Child thread default name thread 0. Thread 0. Okay. Now, instead of printing like this is myself I written main thread word. Now, instead of printing main thread, child thread like this, I want to print default names only. How to print? What do you write? Here, what do you write? Thread T equal to thread dot current thread. Next. Now, in this line, what will happen? Current thread referred by T. current thread referred by T. With the T, which method you have to call? Get name. So here T dot get name. Okay. Now thread dot current thread. Current thread is instance method or class method? Class method. In which class? That is the reason thread dot current thread. Return type is thread. That's what thread T equal to thread dot current thread. Now T dot get name. Name of the thread printed. Okay. Year. Year what we have to write? Suppose. Can I write year also like this? Thread T equal to thread dot current thread and year also T dot get name. Can I write? Yes or no? Yes. File save. Now it is printed. What is? T equal to T. Here already defined. Here T already is there. Here T written. Okay, something T2. T2. Now this T is child thread. Okay. This T can be, this T is nothing but now child thread. Main thread is now T2. This T, can I access here? Can I access? Why? Local variable. This T is a local variable. Now, here new thread will born. Child thread. That thread referred by T. It is child thread. T2. It is main thread. Okay. Compilation. Execution. See. Thread 0. See. Main thread 0. Main thread 0. I want to change the thread name. How to change? Which method? Set name. Here. T dot set name. Suppose here something I'll write demo. Now, is it child thread or main thread? Now, here total how many threads are there? 2 threads. Which thread name I changed? Child thread name or main thread name? Child thread. It is child thread name I changed. Okay. Now child thread name is demo. File save. Compilation. Thread 0 place demo printed. Thread 0 place demo printed. Okay. Now every second one number I want to one time I want to display. What you write? Sleep. Sleep method, instance method or class method? How to call? What we have to write? Sleep. How much? 1000. Will it throw exception? Which exception? Is it checked or unchecked? Is it compulsory to handle? How to handle? Try catch. Try. Here. Catch. Interrupted exception. System dot err dot println ei. Here also I'll write thread dot sleep 1000. Right. Catch. Interrupted exception. system.err.println I. Okay. Now compilation, execution. One is main, one is child. Child name I changed. Demo is a child or main? Child. Main is a main only. Main thread name is main only. I didn't change. Child thread name is thread 0. I change it to demo. Now what I want is here every program contains at least one thread, that is main thread. That main thread will be there. That is no need to create. It automatically comes by operating system. So operating system itself, it will provide one thread for every program. See here present how many programs are running? Edit Plus running, browser running, Zoom software running, Notepad running, and command prompt running. That means 5 threads. Uh, sorry, 5 process, main process you can create child, that is thread. Okay. Now here 5 applications running. 5 application where it is running? Under operating system. Operating system itself, it will provide. One minute. Just call office one. In this program, total 2 threads are there. Online students, 1 minute wait. In this program, child thread name, I change it to demo. Main thread is main only. I didn't change main thread name. Child thread name is demo. Here, you are getting demo. Instead of writing like this, one more way is, what we have to write? Only get name. So just only get name you can write. Here implicitly what will happen here? This keyword. This dot get name. File, save. Like that also you'll get it. Now, 1 minute. This dot get, why it will not work? Reason, think yourself. It actually here, that is in previous class it is worked. Reason, here current class nothing but 1 minute. Here actually get name method in which class? Get name method in which class? Thread class. If I write get name here implicitly what will be there? This keyword. This keyword refers current class. Which is current class? Demo. Demo superclass? Object class. But method in which class? Then how it works? It doesn't work. Okay. Here compulsory you write like this only. Yesterday program different. Yesterday program extends thread. Okay. Here compulsory you write like this only. Here get name method is available in thread class. But if we call directly with this keyword refers demo class object. Demo class superclass is object class. But method is not available in demo class, not available in object class. Method is available in thread class. So compulsory you write like this only. Okay. Now file, save. It is coming just Java demo. If I compile, if I execute like this, you are getting. Now I want to create one more thread. Then what we have to do? I want to create one more thread, but task is same. Task is same. Is it required one more class? No. What you have to do? One more object. See. One more object you have to create. What we have tried? Again, this line also required. Okay. So what we have tried? Runnable R2 equal to new demo. Next. Thread. This is T2. I'll write this is, I'll make it T3. This is T1. I'll write. Edit T1. Edit T1. Edit T1. Edit T2. I'll write. What we have to write? T2 equal to new thread R2. Next. For this one also I want to set the name. Something test. Next. T2 dot start. Okay. Now in this program, how many threads are there? 3 threads. Okay. One is main thread, 2 child threads. 2 child thread will use the same code. Okay. File, save. Compilation, execution. See, main demo test. All are running simultaneously. Okay. Now, main demo test. All are running simultaneously. Now, I'll ask one question, give me answer. This is main thread. Main thread time 1000 milliseconds, nothing but 1 second. Now what I want is, now demo thread using this code only, test thread also using this code only. Now what I want is, for demo thread 2 seconds, test thread 3 seconds I want to set. Now, if I write 2000, then what will happen? Demo thread also 2 seconds. Test thread also 2 seconds. See? Compilation, execution. Now, main will finish first. Demo test, it takes time. Because 2 seconds are given. Now, main completed. Demo test still running. But for demo 2 seconds, test 3 seconds I want to set. What is it? Oh. No, actually, my question is clear. For demo thread, 2 seconds. For test thread, 3 seconds. Here if I write 2, for both the threads, 3000, for both the thread 3000. But I want one thread is 2 seconds, one thread is 3 seconds. Which one? T dot sleep. Thread dot sleep also working. No, why T dot sleep? Which object? It is current object. If demo comes, that is demo reference. If it is test comes, test reference. How it will work? Suppose T dot sleep. Okay. And then for demo also, that is. Test also, that is. So actually sleep method, instance method, class method. It is not recommended to write. That leave it. That if you write also, it will not come. You observe. Now T dot sleep. What it will come? No change. Next. Which one? Here, these variables you are asking. Static variable yesterday. No. This T1 dot sleep, T2 dot sleep. Then what will happen? Will it work like that? Think yourself. If you write T1, T2, T1 dot sleep, T2 dot sleep. Both if you write, how it works? If condition. Use if condition. Use if condition. If thread name is demo, 2 seconds. Thread name is test, 3 seconds. Outright. Answer is if condition. Outright. Here, if T dot get name, what you write? Double equals operator or equals method. You studied no equals method, you studied equals operator, you studied. What you write? Equals operator or equals method? Method or operator? Method. What's the difference between operator and method? Operator compares hash code. Method, content. So what do you write? Dot equals. Here, t dot get name. What it returns? Which type? String. That string object dot equals. Then demo. Then thread dot sleep 2000. Else thread dot sleep 3000. Got it? So if you are getting confusion like this means right here string s equal to t dot get name. After this s dot equals then demo. Like this you can write. Now anyhow we are using 2 times. That's what this is only best option. What you do is this line you write here. Then here while printing also you can print yes. No need to write get name again. Okay. Here t dot get name. Name comes. That name printed. If the name printed, if the name is demo, 2 seconds. The name is other than demo, 3 seconds. Is it clear? So we retrieved name of the thread. If that name is demo, 2 seconds, else 3 seconds. Now main thread 1 second, one demo thread 2 seconds, test thread 3 seconds. Compilation. Whether it is completed or not, if you want to identify number 1, 2, 3, 4, you can print. See, now main completed already. Demo almost completed. Now test only running. Now see, here while printing plus I. Like this I'm printing. Here also. T3 dot get name plus concatenation like this. While printing 1, 2, 3, 4 number printed, with that you'll understand finished or not. Main is finished. Demo test running. Then demo is going to finish over. Test still running. That is 3 seconds. That's what late. Okay. Write this program. See, if you are perfect up to exception handling, you can do so many things, no? Anything you can write. Up to exception handling, who you are perfect, for them remaining all nothing. So one main thread, two child threads. Is it completed? Now, here total how many threads? Three threads. One main thread, two child threads. Main thread name demo test. If you don't set names, what will happen? Thread 0, thread 1 comes. Okay. Now, why two ways to create a multi-threaded application? Okay. Now, you studied there are two ways to create multi-threaded application by extending java.lang.thread class. Second one, by implementing java.lang.runnable interface. Now, think yourself, why two ways? Now, here it is a class. It is a interface. Class interface difference is no. Now, with that concept, we can think we'll get it answer. What is? Think yourself and give me answers. Extends thread, implements runnable. Now, why two ways? Multiple inheritance. So, multiple inheritance purpose only. The Java does not support multiple inheritance with classes, but with interfaces possible. Suppose here one class demo. Okay. Now, here class demo something extends another class is there. Now for this class, if you want to apply multi-threading, what you can do? Extends thread. You can write. For this class, if you want to use multi-threading, extends thread, you write? No. That's what implements runnable. Interface purpose only. What is the what purpose interface introduced? To achieve multiple inheritance. That purpose. Here, multi-threading, if you want to apply with extend thread, you can write. But here you cannot write. Already one more class is there. Okay. In that situation, implements runnable. Okay. Next. Synchronization. Synchronization. Somewhere this definition I given. What is synchronization? It allows only one thread at a time. Okay, right. It is a mechanism that allows to access a shared resource only one thread at a time. It is a mechanism that allows to access. It is a mechanism that allows to access a shared resource only one thread at a time. It is a mechanism that allows to access a shared resource only one thread at a time. See, multiple threads, if it is comes to shared resource, it allows one by one. That is best example to understand. I given printer. This theory part I explained already. Say 5 computers connected together as a one network. 5 computers connected together as a one network. Okay. 5 computers connected together as one network. How many printers required? One printer enough. If we connect to this computer, can I take printout from here? Yes. Like this, all computers can use the same printer. Now, printer is a one resource. Printer is a one resource. Can I call shared resource? Is it printer only for this computer? That's what you can call it as shared resource. All computers can use the same printer. It is shared resource. Now, all people, see here, you observe, suppose printer already printing, performing task. While when you click print button here, possible or not possible? Possible. No need to observe printer. Printer free or busy. You can click print button. You can work your other things. Okay. Now, is it required to observe people clicking or you are clicking like that? Is it required to check? Anybody does? They can click at a time. That is nothing but multi-threading. It is not possible to click. That is nothing but single thread. It is not possible to click. That is single thread. It is possible to click all people at a time. Multi-threading. Multi-threading means execution of more than one thread at a time. All people, they are clicking print button all at a time. That is multi-threading. Single thread means not possible. Not possible to click at a time. Okay. One by one only works. Now, suppose 5 members are working in 5 computers. 5 members, they may click print button at a time. Will it allow at a time clicking or not? Yes, that is multi-threading. If it is not allowing, single thread. Now, like that is there? No. All people can click at a time. Multi-threading. All they'll click. Printer will receive. Will it print all at a time? That is synchronization. Single thread is there. Synchronization is not required. Single thread is there. Synchronization is not required. Multi-threading is there. Synchronization required. Now, printing only at a time, not allowing. Printing at a time, not allowing. That means single thread program. Printing at a time, clicking at a time, allowing. Multi-threading. Clicking not allowing at a time, single thread. Clicking allowing at a time, multi-threading. But printer not allowing to print, synchronization. Suppose, for example, you are coming to classroom one by one. You are coming. No one is saying you are coming one by one. It is like a single thread. But you are coming like a group. Okay. But that is multi-threading type. But there, administrator or office boy will allow one by one. Synchronization is controlling. But you are coming one by one means no one is required. Okay. You are coming like a group means someone required to control. Like that. Okay. Here, it is allowing one by one means, clicking allowing one by one means single thread. Clicking allowing at a time means multi-threading. But printer not allowing at a time means synchronization. Got it, man? Now, suppose single thread program is there. Is it synchronization required? No. Synchronization is not required. In a multi-threading only synchronization required. That synchronization you are going to learn. Note, there are two ways to synchronize the code. There are two ways to synchronize the code. First one, synchronizing a method. Second one, synchronizing a block of code. There are two ways to synchronize the code. First one, synchronizing a method. Second one, synchronizing a block of code. There are two ways to synchronize the code. First one, synchronizing a method. Second one, synchronizing a block of code. Okay. This is, we'll see continuation next class. Tomorrow, I am not coming, but Sunday, I'm going to take the class. Okay. Sunday, only online I'll take. Because many people are asking when batch is going to finish, when batch is going to finish. Okay. Sunday, 10:30 to 12. 10:30 a.m. Okay. Just 1.5 hours I'll take. Sunday, 10:30 to 12 I'll take. Okay. Online only. Only online I'll take. You will get a Google link in a Google Classroom. Okay. Just they will create link. That link they'll send to Google Classroom. Through Google Classroom link, join. Sunday morning 10:30 to afternoon 12. 1.5 hours. Okay. Because many people are asking when batch is going to finish. That's what. Tomorrow no class. Tomorrow I'm not coming. Okay. Tomorrow I'm not coming. We'll see continuation on Sunday at 10:30.